Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the viewers. We are MAT123 or Calculus 1 students wanted to present about application of differentiation. Our group member is consists of four members. The first one will be Johan Muhammad Shazan, continue with Shafiq Haikal, Wan Ahmad Darnish, and myself, and lastly myself, Danish Roslan. At the end of the video, the viewer will be informed of these several lessons, such as first, what is differentiation? Second, application of differentiation. Third, how differentiation are used in our daily basis. Fourth, related rates, and lastly, how to solve question involving application of differentiation.
Now, moving on with the definition of differentiation. Differentiation in mathematics is the process of finding the derivative or rate of change of a function. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge on how to manipulate those functions. Here are the three basic derivatives. Number one is the algebraic function, which involves the derivative of x to the power of n will equal to n multiplied by x to the power of n equal to the power of n minus 1, in which n is any real number. For number two is the trigonometric function, in which the derivative of sine x would be cos, and the derivative of cos will be the negative sign. And lastly, for the basic derivatives are the exponential function, which the derivative of the constant, the exponential constant e to the power of x will be e to the power of x. For functions, the built-up of combinations of classes of functions, the theory provides the following basic rules for differentiating the sum, the product, or the quotient of any two functions, f(x) and g(x), the derivative of which are known. There are the sum and the differences, which involve the sum rule and the difference rule, the product rule, and the quotient rule. And lastly, the chain rule. The chain rule provides a way to differentiate a composite function. If f(x) and g(x) are two functions, the composite function f(g(x) is calculated for a value of x by first evaluating g(x) and then evaluating the function of f at this value of gx.
Now, if you're wondering what is application of differentiation, to solve any problems, the appropriate rate of change is determined by implicit differentiation with respect to time, as you can see in the slide, like dv per dt and dr per dt. If we consider the balloon, we can say that the rate of change in the volume v is related to the rate of change in the radius r. In this case, we can say that dv per dt and dr per dt are related rates because v is related to r.
Problem statement: Wheat is poured at a rate of 15 centimeter cubic per minute into a conical pile whose bottom radius is always half the height. How quickly will the base area increase when the pile is 12 centimeter tall? Hint: volume of conical pile is equal to 1 over 3 pi r squared h. So, from the question, the value given are dv over dt is equal to 15 meter cubic per minute. We need to find dA over dt when h is equal to 12 centimeter. So, to find dA over dt, we use chain rule, which is dA over dt is equal to dA over dv times with dv over dt. Remember, the question tells that radius is always half of the height. So, r is equal to h over 2. Then, h is equal to 2r. The formula for area is A is equal to pi r squared. Then we differentiate this equation. We got dA over dr is equal to 2 pi r. The formula for volume is 1 over 3 pi r squared h. Then we substitute the value of h with 2r. We got V is equal to 2 over 3 pi r cubic. Then we differentiate this equation. We got dV over dr is equal to 2 pi r squared. From the value that we got, which are dA over dr and dV over dr, we can find the value of dA over dV using chain rule. So we just need to substitute the value into the equation, and we got dA over dt is equal to 15 over r. When h is equal to 12, r is equal to 12 over 2, which is 6. So we just need to substitute 6 with r, and we got the final answer is dA over dt is equal to 5 over 2 meter squared per minute.
So now is the part of conclusion. Weight is put at a rate of 15 meter cubic per minute into a conical pile, whose bottom radius is always half the height. When the pile is 12 meter tall, so the rate of base area increasing is 5 over 2 meter squared per minute. So to get the result, we should list out all the information given and using the right formula.
In this slide, we would like to show our gratitude. We are extremely thankful that we were able to complete this assignment assigned by our lecturer, Madam Manwaharati binti Wan Abdul Aziz, within the time frame specified. This assignment will be impossible to accomplish without the extraordinary cooperation and effort of all the other group members. We also truly appreciate our lecturer for all of her willingness and assistance in the making of this assignment. Especially over the past, would like to congratulate our family members for their endorsement throughout this process.